Welcome to a new part of the ISM Statistics 1 exercise set. This time with an exercise on measures of central tendency. Let's consider the exercise. The following dataset resulted from the daily outputs of a factory worker over the last 2 weeks. What should we do with this dataset? First off, prepare frequency table. Second, calculate the mode of the dataset. Third, calculate the median of the dataset. And finally, calculate the arithmetic mean of the dataset. Well, let's jump right in. Before we can, however, jump, we need to do some preparatory work. We need to consider our dataset and sort this dataset in an ascending fashion. So we need to start with the smallest values. That's here 3 times the 200, 210, 230 for a total of 2 times, the 250, 270, and 2 times the 280, 290, and finally the 300. Well, having this ordered data set, now we can finally jump right into starting working on our exercises. For this, we copy this data set and we prepare a random table outlook. Here with 4 different columns, each column containing, well, the first one, the values, the second one, the absolute, third, the relative, and fourth, the cumulative relative frequencies. For the values need to be noted, each value is listed only once. So if we have here 3 times the 200 is only listed once, leading to this array of values. However, to take care about the fact that the 200 is present 3 times, the 280 is present 2 times, we add those in the column of the absolute frequencies. And well, this is already like the first half of this table. For the second half, for the relative frequencies, we just consider how many observations we have, in this context 12, and we divide all the absolute frequencies by the number of observations. So we start with 3 divided by 12, giving us 1/4, 1 divided by 12, 2 divided by 12, and so forth. This is still relatively easy. However, if we continue with the cumulated relative frequencies, what do we have to do here? For the cumulated relative frequencies, we always take the value from the row above and add to this the relative frequency of the current row. So for the first entry, well, there is no previous row, so we take 0 plus relative frequency of the current row, 0.25, so we get a cumulated relative frequency of 0.25. So we go into the next row for 210. Here we add to the 0.25 the 0.0833 and get a cumulated relative frequency of 0.333. To the 1/3, the 0.333, we add the relative frequency of the current row, the 0.1667, and we get a cumulated relative frequency of 0.5. And we could carry on for the whole of the rest of the table. The only important thing, take care that in the end you always arrive at 1.0, 100%, else somewhere in between something might have gone wrong. Because in the end, all frequencies cumulated, added up, need to add up to 100%, else something is really off with whatever has been calculated. However, well, this frequency table is now complete. We concluded the first part of this exercise, and we can use this data set, we can use this frequency table to directly solve part 2 as well. In part 2b, we need to calculate the mode. How do we get the mode? The mode is the most frequent value. So we take a look at the absolute frequencies and select the row with the largest entry. Here, clearly the largest value is 3, so the corresponding value 200 gives us O mode. This has been easy, so let's carry on in the same style with part 3 with calculating the median. For the median, however, we use the ordered data set. So we again copy the ordered data set from previous slide. And what do we actually calculate with the median? Well, this depends on the number of observations, because there's actually two versions of the median, one for an even number of observations and one for an odd number of observations. Here, well, we have seen this already, we have 12 observations, so clearly we have an even number of observations, meaning we need to use this first formula. For the first formula, we first need to calculate the two indices. First one is 1/2 times n, so 6. And the second one is one larger, so it's 7. So we need to find the 6th and 7th entry in the data set. If we look closely, we can see the 6th, that's the 230, the last 230, and the 7th, that's the 250. So we need to add 230 plus 250 and multiply all of this with 0.5, giving us a result of 240 for our median. Finishing the third part of our exercise. Well, the only thing remaining is then calculating the arithmetic mean, and there we have three different possibilities. The first one we get relatively easily by just considering the ordered data set and adding up all the observations. After having added up all the observations, we just divide them by the number of observations, getting a result in the way as done here as 245. Well, this is relatively intuitive and relatively easy. However, this can become relatively tedious if you have quite a lot of data points, if you have a very big data set. So to make our life a little bit easier, there are two possible alternatives to this. The first alternative considers the frequency table and just goes and multiplies the values and the absolute frequencies and adds this result up, and in the end the final sum is divided by the number of observations. Here we can see an application for this. Well, this is slightly less than what we did in the part before. However, this approach only pays off if you have a large number of values with absolute frequencies larger than 1. So here we only have 3 values with an absolute frequency larger than 1, and then we only have like absolute frequencies of 2 and 3. So here this is not as important. But with very big data sets, this can become very important very fast. However, this is the idea behind this, and obviously in the end we get the same result, the same 245 as with the first approach. And also the third approach, well, it starts similar. We again consider the frequency table. It basically does the same thing as the first alternative, so what we did the slide before. However, we do not multiply values and absolute frequencies and divide this by the number of observations. We directly, as we can see here, multiply the values with the relative frequencies. So we do not have to divide by the number of observations. This then looks like this. And well, again, the comment as before, this only really pays off if we have a lot of observations with absolute frequencies distinctly larger than 1. However, here again we can see, depending on which approach we use, we get the same result of 245. Then, well, this is the third alternative to our part D, so the final part of this exercise. And this result also concludes this exercise. So I hope all of you enjoyed listening and learned at least something from this exercise. Until next time, see you and goodbye.